Hello everyone. In this lecture, we are going to see something about the ignition systems, its components, functions, requirements that are there in an IC engine. Now, why do we need an ignition system? For the combustion of the fuel-air mixture to start, the fuel needs to be ignited, and this fuel to get ignited develops the need for an ignition system in case of an internal combustion engine. Now, let us see what are the functions that are desired out of a ignition system in case of an IC engine. The first and foremost is it should be able to generate a spark such that this spark should have enough heat to ignite the air fuel mixture in the combustion chamber and to start the combustion of the fuel air mixture. Other than this, the spark should be able to be maintained for a time that is sufficiently long enough so that the total combustion of the air and fuel mixture in the cylinder is able to get completed. Another point is to deliver the spark in case of a multi-cylinder engine to each particular cylinder so that the combustion might begin at the right time for an individual cylinder during the combustion stroke. The ignition system, it plays a very vital role. Now let us see what are the different components of an ignition system. The first one is the power source. The power to develop the electric spark through the supply of voltage is derived by three different things: magneto, capacitor, and a battery. Other components are the primary coil and the breakpoint. This breakpoint, it has mechanical contact breaker or electrical contact breaker. Then the next thing is the secondary coil, distribution system, and in distribution system we have a mechanical distributor and an electrical distributor. Then finally you have the spark plug. Now let us go on a bit further. Now this is an example of a battery and coil ignition system. This is a very basic component in automobiles nowadays. The different components over here are a battery, a 12 volt or a 6 volt battery which serves as the power source. It is connected to the ignition switch through an ammeter. This ignition switch, it is connected to the primary winding, which basically might contain 200 to 300 turns of 20 gauge wire. This primary winding is connected to the secondary winding through a coil. This secondary winding, it might contain larger number of turns of a higher gauge wire. As you can see over here, the number of turns that we are considering is 2100 and a 40 gauge wire. This secondary coil is in turn connected to the distributor. The distributor, as we can see over here, it rotates in a clockwise direction, and there are four different points present along the circumference of the inscribed circle, wherein we can see that different spark plugs for each individual cylinder, that is 1 2 3 and 4, they are connected. The voltage available across these distributor contacts, as we can see, is 20,000 to 30,000 volt. Also, in addition, you have a contact breaker circuit connected with a capacitor. Now, how does this system is going to operate? As we have already seen, the source of ignition energy in this system will be the ignition coil. This coil serves the function of storing the energy in its magnetic field, and it will deliver this energy as and when required at the time of ignition for each particular cylinder. This will be delivered in the form of a high voltage current through the high tension ignition cables to the required spark plug. Inductive process is the principle on which the energy is stored in the magnetic field. The ignition coil, as we have already discussed, it will contain two coils of wire. Okay, one will be wound around the another, and both will be insulated with respect to each other. The primary winding we have already seen, it has lesser number of turns as compared to the secondary winding. These windings, they have a laminated iron core around which they are wound. This will have the effect of increasing the strength of the magnetic field, and as a result of this, the amount of energy that is stored will be increased considerably. We have seen that end of the primary winding through the ignition switch is connected to the positive terminal of the battery. Okay, and also we see that the other end is grounded through the contact breaker. Fine. Capacitor, we have already seen, it is connected in parallel with the contact breaker. Then again, the secondary winding has one of its end which is grounded through the contact breaker, whereas the distribution system has the other end of the secondary winding which is connected. Then, as soon as the ignition switch is closed, the primary of the coil is connected to the positive terminal of the battery. If the primary circuit is closed through the contact breaker, a current will flow. This will be called as a primary current. As soon as this current flows through the primary coil, it is going to produce a magnetic field in the core. Okay. Then the engine is going to drive a camshaft which is so arranged so that it will open the breaker point whenever discharge of ignition is required. As soon as the breaker points open, the current which was flowing through, it will now flow into the capacitor, which is, as seen, is connected across the point. As soon as this becomes charged, that is, as soon as the charge is stored inside the capacitor, the current in the primary will fall, and as a result, collapse of magnetic field in the coil is going to take place. As soon as the field collapses, it will induce a voltage in the primary winding, which will then charge the capacitor to a voltage which is much higher than the battery voltage. Now, this capacitor will discharge into the battery, as a result of which the direction of primary current and the magnetic field is reversed. The collapse and reversal of the field in the coil will induce a high voltage in the secondary winding of the ignition coil. As a very large number of turns are comprised in the secondary winding, which is bound on the same core with the primary, this will lead to a proper spark plug by means of a rotating switch, as we see in the diagram, which is called as the distributor. Now, if we consider that the capacitor is not placed in the primary circuit, what is going to happen? The primary voltage, which is caused by the collapse of the magnetic field, it will cause an arc to take place across the breaker point. This arc has the capability to burn the points, and also by extension it will prevent the rapid drop in the primary current and the magnetic field. And these two concepts, these two facts, that is drop in primary current and the magnetic field, is extremely necessary for the production of high secondary voltage. Now, there are certain limitations that are associated with this ignition system. The first one is the decrease in the primary voltage, which is take place as there is an increase observed in the engine speed. This is because of the limiting capacity in the current switching capability that is there in the contact breaker system. Then another point is that the buildup of current, the time which is available for this in the primary, and the stored energy, it will decrease as the engine speed increases. Then another point is, as high source impedance is present, the system it is extremely sensitive to side tracking across the spark plug insulator. So these were the some limitations associated with this battery and coil type of ignition system. Let us go on further. Ignition timing. We have already seen and we already know that after compression takes place, the piston is present at the top dead center and the whole charge that was drawn in during the suction stroke, it has been compressed. Ideally, the spark should take place after the compression stroke is completed. However, this will not happen and this should not happen. Why? Because the piston will not remain stationary and wait for the charge to start burning. It will keep on moving, and if we pass the spark right at the point when the piston is at top dead center, then by the time the fuel starts to burn and release high amount of pressure and energy, piston will already have gone down in the expansion stroke and rotated by some degrees of crankshaft angle rotation. This will result in a loss of power. So what we need to do is we need to pass the spark a little bit before the compression stroke is completed and the piston arrives at top dead center. What will happen because of this? This will change as the engine speeds up because fuel can only burn at one rate of speed. Then the piston could move faster when the fuel burns, which means that the piston could be gone from TDC before the fuel can push down on the piston, as we have already discussed. Now these diagrams, they represent what we have discussed right now. The spark in the first case, it will occur 18 degrees before TDC, that is before the piston reaches top dead center of 18 degrees of crankshaft rotation. The spark will take place. It will remain for 41 degrees of crankshaft angle of rotation, that is 41 degrees of travel, and combustion will end at 23 degrees of crankshaft rotation after top dead center in the first case, and the same thing is more enhanced, and the spark occurs 40 degrees before top dead center. It has 63 degree of crankshaft angle of rotation travel, and the combustion will again end at 23 degrees after top dead center. Now these two examples, they reinstate what we have discussed, that as the engine speed increases from 1200 to 3600 rpm, the spark advance needs to be increased. In the first case, it has to be at 18 degrees before TDC, and as the engine speed increased, it was taken to around 40 degrees before TDC. Okay, let us go on a bit further. Now let us see another type of an ignition system, which is the magneto ignition system. In this case, you don't have a need for an outside primary source of electricity such as battery, which was being used in a battery and coil type of ignition system. This magneto ignition system is primarily applicable in small gasoline engines such as lawnmower, chainsaw, etc. This is the basic circuit of a magneto ignition system. You will find that it is mounted on the engine, and it will replace all the components of the coil ignition system except the spark plug. The principle underlying this system is that when a magnet is rotated by the engine, it is capable of producing a high amount of voltage, and for this it will not require a battery. The high tension magneto, it incorporates the windings to generate the primary voltage and also to step up the voltage, and it does not require a separate coil to boost up the voltage required to operate the spark plug. This system can be of two basic types. One is rotating armature and another one is rotating magneto. In rotating armature type, the armature will consist of primary and secondary windings, and they all will rotate between the poles of a stationary magnet. As far as the second case, that is rotating magneto type, is concerned, the magnet will revolve and the windings are kept stationary. Okay. Now, the working principle underlying this system is near about same as that in case of coil ignition system. Okay, the main disadvantage of this system, it lies in the fact that the windings that are used, which will carry a high voltage, there is a possibility of causing engine misfire due to leakage. If the voltage is leaked, then misfiring of the engine might take place. If we compare a battery and coil ignition system with magneto ignition system, there are certain differentiating points. The first one is that in ignition system, a battery is used to generate the energy, and it will be a little bit difficult to start when the battery is discharged. However, in case of a magneto ignition system, no battery is required, and as a result of which there is no problem of battery getting discharged and subsequent starting of the engine. As soon as you incorporate an additional element of battery, the maintenance problem will start in case of battery ignition system. However, in case of magneto ignition system, these problems are absent. The battery, it will provide the primary current which is required to generate the energy. However, in case of magneto ignition system, it will be provided by the magneto. Then another point of differentiation is that in case of a battery ignition system, the spark available is of a good quality at the spark plug even when the speeds are low. However, in case of a magneto ignition system, as you start the engine and the engine speeds are low, the quality of spark is poorer. Also, the efficiency in case of a battery ignition system, it will decrease with the reduction in spark intensity as the engine speed is going to increase. However, in case of magneto ignition system, the efficiency of the system will improve as the engine speed rises due to high intensity spark. As an additional element is present in the form of battery to supply the required energy, it is going to overall occupy a larger amount of floor space in the engine. Whereas in the case of a magneto ignition system, it will occupy a less space. So these were the basic differences between a battery ignition system and a magneto ignition system. Now let us go on a bit further. Another ignition system is the CDI, that is Capacitor Discharge Ignition System. It employs the use of thyristor or SCR, which stands for Silicon Controlled Rectifier. This ignition system is also widely used in outboard motor, lawnmower, turbine powered aircraft. As you can see, a magnet is used and a charged coil is present. As a result, of the movement of magnet as indicated by the red arrow, an alternating current is produced. A rectifier is used and this is converted into a direct current which is stored in the capacitor in the range of 300 volt maximum. Then you have an SCR, that is silicon controlled rectifier. This rectifier will, as and when required, supply this DC voltage to the primary of the sparking coil. As a result of this, a higher voltage in the range of 30,000 volt is generated in the secondary of the coil, which is connected with the spark plug. And this SCR, it is operated by a trigger coil, which is again based on the principle of magnets. Then another one is the distributionless ignition system. It will use battery power as the primary source of electricity, and it will have two types, that is direct ignition system or distributorless ignition system. In most gasoline engines for the vehicles of the recent make, this type of ignition system is used. As you can see, there is a timing disc instead of a distribution distributing system which is coupled with the timing sensor. It will sense the speed of the engine, and depending upon it and the stroke of the particular cylinder, it will actuate the individual spark plug and provide the spark. In case of a multi-cylinder engine, the ignition system, it needs to consider one more problem, and that is of the firing order. If we consider a four-cylinder engine, here we are seeing that the firing order is 1 3 4 2, that is the consecutive cylinders are not going to fire simultaneously or consequently. By firing, we mean that the development of expansion stroke. If we consider that one after the other, the cylinders fire sequentially, that is, expansion stroke is produced in the cylinder sequentially in the order 1, 2, 3, 4. All these pistons, along with their connecting rods, in case of a four cylinder inline engine that we have considered is connected to the single crankshaft. If the subsequent engines are sequentially fired, then the individual region of the crankshaft will be subjected to very high loads as far as the pressure is concerned and also as far as the heat is concerned. This will lead to the failure of crankshaft. Hence, in order to avoid this, the firing order is thus maintained as we are seeing in the table for different number of cylinder arrangements. Okay, so this was something about the ignition systems that are used in the internal combustion engines. Thank you very much.